Okay, good morning. Welcome back to our discussion. So, as a continuation in the application of the first order, first degree DE, so we will be discussing now in problem involving temperature now governed by the Newton's law of cooling. Now, the time rate of change of a temperature of the body is proportional to the temperature difference between the body and the temperature of the surrounding. Now, let your T be the temperature of the body at any time T. So, it is a function of time. No? So, the T sub M represents the temperature of the outside medium. No? So, temperature of the surrounding. So, air temperature. Okay? Now, according to the Newton's law of cooling, so the time rate of change and the temperature of the body denoted by T is directly proportional to the difference between the temperature of the body and the surrounding temperature or the temperature of the outside medium. Now, in order to form an equation, so I introduce the constant of proportionality K, and I notice that the dE form is a variable separable dE. So I can proceed with the variable separation. By the way, your K is a constant. So separating our variable, letting one side be 0. So I can now do the integration to obtain the general solution. So we have the integral of du over u form. So we have ln of t minus t sub m minus k times t equal to c. Now what I want to arrive is to arrive with a functional relation of a variable temperature t and the time t. Okay? So for a particular solution, so I have to consider boundary conditions. I can take the initial condition where I have t equal to 0 or the time is equal to 0 and the temperature of the body is equal to the initial body temperature, which is termed as the T sub O. Now substituting to the ln of t minus t sub m minus kt equal to the arbitrary constant c. Okay, so we have the ln of the t sub o minus t sub m minus k times 0 equal to c. So your c is equal to the ln of the difference of the initial body temperature minus the temperature of the surrounding. So, substituting back to the general solution, so I can obtain the ln of t minus t sub m minus kt and the ln for your c. Now, that's the ln of t sub o minus t sub m. Now, arranging my terms. So, I take the ln terms at the left and the other term, k times t, is placed at the right. Now, applying the property of logarithm, because I want to simplify to arrive at the function temperature as a function of time. Okay, so we have two logarithmic terms expressed as a difference. So I can form a ratio and we have k times t. To remove my ln, I take an exponential both sides. Okay, so there I arrive for the exponential of ln of a function. So it's the function that will be your simplified form. And I have the exponential of k times t. Now, if I'm going to multiply with my LCD so that t minus t sub m is equal to the product of my denominator multiplied with the exponential kt. So solving for t, so it is equal to the t sub m plus the t sub o minus the t sub m multiplied with the exponential kt. And this is a formula which can be used to find the temperature of the body at any time t. So instead of solving a problem in a similar way as we derive, so we can go directly to the application of the formula derived from the Newton's law of cooling. Okay, so here is a problem that applies the formula we derived. So the rate at which the body cools is proportional to the difference in the temperature between the body and the surrounding atmosphere. Okay, so that is a redefinition of the Newton's law of cooling. Now here is a condition. If the body in air at, so this is the surrounding temperature, which is 10 degrees Fahrenheit, will cool from 200 degrees Fahrenheit to 100 degrees Fahrenheit in 40 minutes. So which means the initial body temperature is equal to 200 degrees Fahrenheit. Air temperature is 10 degrees Fahrenheit and the temperature drops now because the surrounding temperature is at lower temperature compared to the body temperature. So, it drops from 200 to 100 degrees Fahrenheit in a matter of 40 minutes. Now, you are asked to find how many more minutes. So, meaning, pila itong idugang from 40 minutes in order that the temperature will cool from 100, no, because it takes 40 minutes to reach 100 degrees Fahrenheit to mo drop siya to another 50 degrees Fahrenheit. Okay, now find the temperature of the body after another 45 minutes, no? So from the initial, so we have another 45 minutes, which means so there will be 85 minutes, no, needed in B from the initial. The time taken for the body to decrease its temperature from initial to within half degree of the surrounding temperature. So which means, may half degree of the surrounding temperature, it means that the temperature difference will only be 0.5 degree Fahrenheit. Okay? So if nagsugod ta og 10 degrees Fahrenheit and then ang atom body will cool down approaching this surrounding temperature, so that means mag-drop siya. So, mo ni ihang kinaubusan nga, mo ni ang temperature sa surrounding. So, if there's a difference of 0.5 degree Fahrenheit, so the temperature of the body can be 10.5 degree Fahrenheit. So that the difference of the temperature of the body and the temperature of the surrounding will be equal to 0.5. If the temperature of the surrounding or the body is much less than the temperature of the surrounding, so ang imuha karong body temperature will be less than the room temperature. So if may kag within half degree of the air temperature, so the body temperature during the time can be equal to pila 9.5 para the difference can be 0.5 only. But on this case, the body temperature is higher than the surrounding temperature. So when it will drop, so it will approach 10 degrees Fahrenheit. So in letter C, the body temperature can be pila 10.5 degrees Fahrenheit. Let us collect the different given. Boundary condition initial, so that is when T is equal to 0, the initial body temperature is 200 degrees Fahrenheit from the given. Surrounding temperature is 10 degrees Fahrenheit. After 40 minutes, no? So the body temperature drops from 200 to 100 degrees Fahrenheit. Okay, now the required, okay, so as we mentioned ganina, so we have this A, B, C. Okay, so ato lang tinagsaon o pakita niya. Okay, now before solving for the required, I have to consider the formula that we derived. Okay, so from the formula we have T is equal to T sub M plus the T sub O minus T sub M multiplied with the exponential K times T. We have the value of the surrounding temperature. We substitute, that's 10. T sub O, what's T sub O? 200, correct? Then minus the surrounding temperature, which is 10. So there is a difference of 190 degrees, and that is exponential K times T. Now, this formula can be completed if we also know the value of K, the constant of proportionality. Now, usually, there is a condition where there is a known time and there is a known body temperature. So, you can use that in solving for the value of your K. Okay, so when your T is equal to 40 minutes, you substitute to the formula here. Okay, now we have an unknown that is left, which is K. Now your calculator can solve a value of your K using the solve function. So from your calculator, you may be given a value which is like this. Now if your calculator fails to evaluate with the value of K, so you can also do the simplification before you can go with the value of K. Now, 90 is actually coming from where? Now, before I take my ln, I have to subtract 100 minus 10, that's 90. I divide it with 190, so there's a ratio of 90 over 190. So, what is left on the other side is the exponential of 40K. Now, in order to solve for your K here, this is E as my base. So, I take ln both sides of my equation. So, I have the ln of exponential 40k can be 40k, which is now equal to the ln of the ratio of 90 over 190. So this is evaluated and you will arrive with the same value of your k. Now, after solving for the value of k, you can go back to your temperature equations. Okay, so we have the body temperature at any time t expressed as a function of time. So, doon na tayo kompleto nga mga value. So, we have 10 plus 190 plus 190 exponential. Then, you can now put the value of your k. Okay, so I did not round this up, no? Para my answer later can be accurate. Okay? Now, in finding what is needed in A, okay, so from the formula, we obtain kompleto siya with the T sub M, with the temperature difference, T sub O minus T sub M, and the value of your K. Then I can now solve what is needed in A. So in A, naingon siya, what time is needed so that ang ato karong temperature will become 50 degrees Fahrenheit. So substitute to the equation in T. So we have 50 here for our T. This is 10 plus 190 exponential, and the unknown here is T. So it takes pila? T equal to 83.41 minutes, and this is based from the initial. Okay, now, ang atong question is not really based from the initial, but it is based from 100, no, to 50 degrees Fahrenheit, no, the body temperature. So it needs the difference, because it needs pila 40 initially to reach 100 degrees Fahrenheit. So the 40 minutes is now subtracted to this computed time, no? So it needs another 43.41 minutes to cool the body from 100 degrees Fahrenheit to 50 degrees Fahrenheit. Now in letter B, what is the temperature reading if we have to take 45 minutes more from the initial? So it means if the initial takes 40 minutes and there is 45 minutes more, so the 45 minutes more is added to 40. That's why we have T equal to 85 from the initial, because this formula is based from the initial. Okay, so we have 10 plus, okay, so we substitute value of T, and that's 85. So we come up with a body temperature equal to 48.83 degrees Fahrenheit. In letter C, okay, so what is the time needed if the body temperature is within half degree of the air temperature? So the body cools down, now influenced by the surrounding temperature, so with a difference of 0.5 degree in the air temperature, so the body temperature can be 10.5 on that case. Now, you will notice now that if this is 10, this is 10.5, when you subtract, so there is a difference of 0.5. Okay? So, we have pila 10.5, and we have 10 here, plus 190 exponential with an unknown value of your T. So, you can have your calculator to obtain this. So, we have a number of minutes from the initial. So, it takes 318 minutes to cool down up to a body temperature of 10.5 degrees Fahrenheit. So it's a matter only of substituting to the formula. The formula can be completed if doon na siya value sa K. So you can now be ready, no, to substitute that or to solve for the required, no, by simply using the formula we arrive. Okay? Now another problem. Okay, actually, pareho ragon ni with the first, no? So, nag-mention siya of time. So, at 1 p.m., there is a thermometer reading 70 degrees Fahrenheit, which is taken outdoors where the surrounding temperature is minus 10 degrees Fahrenheit. Okay? Or that is 10 degrees below zero. Now, at 1:02 p.m., the reading, simply, it will drop. No? So, it becomes 26 degrees Fahrenheit from 70 degrees Fahrenheit. Okay? At 1:05, the thermometer is taken back indoors where the temperature is fixed at 70 degrees Fahrenheit. So, if this is the room temperature. So, muna ni imong T sub M in the indoor condition. Now, what is the reading, the thermometer reading when it is observed at 1:09 p.m.? So, let your T be the thermometer reading at any time T. So, we have to consider both outdoor and the indoor condition. So, 1 p.m., okay, so sa 1 p.m., initially, so time is 0, so the T sub O is 70 degrees Fahrenheit. Temperature of the surrounding is minus 10 degrees Fahrenheit. So I simply collect the given here. And at 1:02, meaning it takes 2 minutes, and the reading becomes 26 degrees Fahrenheit. Now, when it is taken back indoor, so there is actually a corresponding thermometer reading which is not mentioned in the problem. So, this is an unknown, When the thermometer is taken back indoor, so wala tay nahibaw-an pa nga temperature reading. But this can be solved, Okay. In the indoor condition, which is at 1:05, this is again where our initial time is set to 0. So our initial body or thermometer reading on that time will be the same as the thermometer reading after 5 minutes in the outdoor condition. So you need to have this because this will serve as an initial thermometer reading at an indoor condition. The body temperature has a reading at T of 5 or temperature when ang atong reading was taken at 1:05. The T sub M, the temperature of the surrounding, is the room temperature which is 70 degrees Fahrenheit. At 1:09, then you are asked what is the thermometer reading. So meaning, from the initial 1:05 to 1:09, so it takes 4 minutes. So what would be the thermometer reading under this time? Now, in order to solve this, so you can start with the outdoor condition. Okay, using the same formula. What's the formula? Okay, so T is equal to T sub M plus the T sub O minus T sub M exponential K times T. What is the temperature of the surrounding? That's minus 10 degrees Fahrenheit plus 70. This is 70. Then you subtract with another negative 10. So 70 minus a negative 10. So that means that is 80. Exponential K times T. So what is lacking here is the constant K. Okay, where to get the value of your K? It mentions that at 1:02 p.m. or 2 minutes elapse, the reading becomes 26 degrees Fahrenheit. I substitute that to this equation above, and by substituting to the equation above, I have 26 equal to the negative 10 plus 80 multiplied with exponential K times 2, correct? Okay, so this equation will actually arrive to a value of K which is this one. Okay, so you can have this calculated directly from your calculator, or you can simplify before you can arrive with the value of K. So my equation for my thermometer reading will now be completed providing a value of your calculated K. So that is, this is the equation. Now what is the reading in the thermometer at 1:05 or 5 minutes after? Okay, so we can substitute this. This can be substituted with 5. Okay, so the reading can be pilaman. Okay, that is 0.867 approximately degrees Fahrenheit. Okay? Now, in the indoor condition, when the thermometer is taken back indoor, so gipagawas, then sunod ato na siyang gipasod. Okay, so we have 1:05 p.m. It's taken indoor, where T is equal to 0. So I have the initial thermometer reading, which is the thermometer reading or the temperature we calculated at the T sub 5. Okay? So we have the initial room temperature 70 degrees Fahrenheit. At 1:09, 4 minutes later, we are now asked to determine what is the thermometer reading. Okay, the formula will be the same, but we will be changing the values of T sub M, the difference of the T sub O minus T sub M, and then kompletohon na to na siya. So T is equal to, saan T sub M? 70 plus T sub O is the T sub 5 which is calculated, which is kini, minus 70. Then exponential, by the way, if you notice, unlike with the outdoor condition where after mentioning initial, there is another condition that mentions time and temperature reading. So there is initial, but immediately you are asked to give the thermometer reading at a certain period. No? It is because we don't need anymore to solve for the value of K because your K will be the same in the outdoor condition. So the outdoor condition K is again used on the indoor condition because it is just the same working with a line where you consider 2 points. So if ganina, we consider point 1 to point 2, say nagdetermine tag slopes, no? So the slope from P1 to P2 will be the same as the slope from P2 to P1. So that is why I can take the same constant, no? Because pwede raman na nato magamit ang atong K from the outdoor condition. So I have a constant here. Okay, so we have a value of our time which is pila 4 minutes. We substitute and we have the reading which is the only unknown, no? So we can solve for that out from this equation and we arrive with a thermometer reading at 109 which is equal to 56 degrees Fahrenheit. Okay, so this is the way on how to solve problem, no, related to the Newton's law of cooling sa temperature problem. Okay, so thank you for watching and thank you for being with us. Okay, so bye-bye and good day.